Near Boston, 1868. George Hammond's locomotives tear down the tracks carrying cargo that shouldn't exist. Fresh beef hanging from crude metal racks inside wooden boxcars. The train hits a sharp curve, and thousands of pounds of carcasses swing in unison like massive synchronized pendulums, lifting the wheels off the rails. The wreckage proves that ambition cannot override mechanics. They tried to conquer distance but forgot to conquer the physics of the meat itself. The livestock equation. To understand why that train ended up in a ditch, you have to look at the world the way Gustavus Swift did. Where others saw cows, he saw an equation that didn't balance. In the 1870s, if you wanted a steak in New York, that steak had to walk there, or at least ride there while still breathing. The entire American food system was built on the livestock model, a massive, sprawling industry designed to move living creatures from the pastures of the West to the butchers of the East. But to Swift, a man who counted every penny, this system was absolute insanity. Here's the math that kept him up at night. Take a standard steer. It weighs about 1,200 pounds, but you can't eat a steer. You eat beef. And once you strip away the horns, the hooves, the hide, and the bones, that 1,200-pound animal only yields about 400 to 500 pounds of actual meat. The rest, roughly 60% of the animal, is waste. Now, multiply that by a train schedule. A standard cattle car in those days held about 20,000 pounds of livestock. Do the math, and you realize that for every single car chugging across the Great Plains, the locomotive was hauling 12,000 pounds of inedible bone, fluid, and gristle. That's 6 tons of garbage per car, burning cold across a continent, only to be thrown away when it reached New York or Boston. But the railroads looked at the exact same equation and saw a gold mine. Railroads charged by the pound. They didn't care if the weight was filet mignon or heavy femur bones. In fact, they preferred the bones. Live cattle were heavy. They were predictable. And the railroads had spent millions building the infrastructure to handle them. Massive stockyards in Chicago, watering stations every few hundred miles, feeding pens along the tracks to keep the cargo alive. They were in the business of hauling weight, and efficiency was actually bad for their bottom line. If Swift figured out how to leave that 60% waste in Chicago, the railroads would lose 60% of their shipping revenue overnight. This economic perversity protected a decentralized, pre-industrial world. The local butcher was king of his domain, but also a prisoner of biology. He bought cattle off the train, slaughtered them in the back, and sold what he could. A system entirely dependent on local weather and immediate demand. If it was too hot, you didn't kill because the meat would rot before you could sell it. If the train was late, you had no product. It was quaint, it was local, and to a rising industrialist like Swift, it was agonizingly slow. He knew the answer was simple: slaughter the cow in Chicago, turn the waste into glue, soap, and fertilizer, right there at the source, where you could do it at scale. Then ship only the dressed beef to the east. It would cut shipping costs in half and lower the price of meat for everyone. The perfect plan with one massive glaring problem. As George Hammond found out on that curve near Boston, dead meat doesn't travel well. The physics of decay. Gustavus Swift was a man who understood margins, but he wasn't an engineer. He knew the economic necessity of shipping dressed beef, but he lacked the technical capacity to make it survive the journey. The physics of decay were winning the war against his ledger. Every day that passed without a solution meant another day the railroads strengthened their stranglehold on the livestock system. Every failed experiment meant another fortune lost to rotting meat and broken dreams. Swift could see the future clearly. He could calculate every dollar it would save, but he couldn't build it. He needed a partner who could think in terms of thermodynamics rather than profit and loss. He found that partner in Andrew Chase. Chase wasn't a butcher and he wasn't a railroad man. He was a problem solver who looked at a refrigerator car and saw a failure of airflow. Where others saw the challenge of keeping meat cold, Chase saw the challenge of keeping air moving. The industry had already produced plenty of failed experiments. These early iceboxes on wheels were crude, desperate attempts to cheat nature. Most designs simply packed ice directly against the meat or piled it in the corners of the car. The result was disaster. The ice melted, creating a humid, stagnant environment that accelerated mold growth. The moisture condensed on the meat's surface, creating perfect conditions for bacteria to flourish. The meat that arrived in the east might have been cold, but it was also wet, gray, and discolored. It looked like death, and no butcher in Boston wanted to put a gray steak in their display case. Customers wouldn't buy it. The economic model collapsed before it even started. Even worse, these cars suffered from the dead air problem. Cold air would settle at the bottom of the car, freezing the lower cuts of meat solid, while warm air rose and spoiled the top quarters. You'd open the car at the destination and find the bottom layer frozen into unusable blocks, while the top layer had already begun to rot. An uneven, inefficient mess that ruined more product than it saved. Some inventors tried adding fans or mechanical circulation systems, but these required constant power, added weight, and broke down with the vibration of the rails. Others tried different insulation materials or complicated systems of drains and vents. Nothing worked consistently. Chase realized that the problem wasn't the temperature, it was the circulation. The ice could provide the cold, but without movement, the cold just sat there, useless and static. He designed more than a box. He created a machine that used the natural laws of physics to create a self-sustaining engine of cold. His breakthrough was the ventilated refrigerator car, a design that seemed counterintuitive to everyone else in the industry. Instead of putting the ice on the floor or the sides, Chase elevated it. He built massive ice bunkers into the roof of the car. To the railroad men, this looked like insanity. Putting the heaviest part of the cargo at the highest point seemed like a recipe for another derailment. Hadn't they just learned that lesson from Hammond's disaster? But Chase understood the behavior of air in a way they didn't. The physics of the Chase car were elegant in their simplicity. Cold air is denser than warm air. By positioning the ice at the top, the chilled air naturally sank, cascading down over the meat like a heavy, invisible waterfall. As this cold air absorbed heat from the beef, it became lighter and began to rise. Chase installed ventilators that guided this warmer air back up to the ceiling, where it was forced over the ice bunkers again, a perfect convection loop. Chase's convection engine. The car didn't need a motor, fans, or coal to run. It simply used the heat of the meat itself to power the circulation that kept it cold. This constant cycle of falling cold air and rising warm air ensured that every inch of the car remained at a uniform temperature, drying the air and preserving the bright red color of the beef. It was a self-regulating system. As long as there was ice in the bunkers and meat in the car, the convection loop would maintain itself across 1,000 miles of track. But Chase also solved the lethal geometry that had destroyed the Hammond train years earlier. By redesigning the interior, he changed how the load was distributed. Instead of hanging the carcasses loosely, where they could sway and generate momentum, the Chase car allowed the meat to be packed tightly, often utilizing the floor space to lower the center of gravity. The load became a solid, unified block rather than a collection of swinging pendulums. The car hugged the track, stable even at high speeds on sharp curves. The engineering was brilliant, but the implications were terrifying to anyone who had built their fortune on the old system. This wasn't just a better icebox. It was a weapon that could bypass stockyards, defy weather, and deliver a perfect product from Chicago to the Atlantic Ocean. Swift finally had his weapon, the machine that could make his mathematics real. But having the perfect car didn't matter if the men who owned the tracks wouldn't let you run it. The numbers told Swift everything he needed to know. A dressed beef carcass weighed roughly 400 pounds. A live steer weighed 1,200 pounds. If he could ship dressed beef instead of live cattle, he would cut shipping costs by 2/3. The railroads would lose 2/3 of their revenue. They would never allow it voluntarily. Swift knew this. Chase knew this. They built the car anyway. The first test runs in 1877 were conducted in secret. Swift leased a handful of cars and ran them on short routes where he had personal relationships with local railroad managers. The results exceeded every expectation. Beef arrived in perfect condition, bright red, firm, cold. The ventilation system worked exactly as Chase had calculated. The convection loop maintained temperature without any mechanical assistance beyond the ice itself. The economics were even more stunning than Swift had projected. Not only did he save on shipping costs, but he could now slaughter year-round. The local butcher had been constrained by seasons. You couldn't kill cattle in July because the meat would spoil before you could sell it. Swift could kill in July and ship to markets 1,000 miles away. He had conquered both geography and time. The dressed beef arrived fresher than anything a local butcher could provide because it had been chilled immediately after slaughter and maintained at a constant temperature throughout the journey. The local butcher's beef sat in a warm shop, exposed to flies and fluctuating temperatures, slowly decaying. Swift's product was superior in every measurable way. cheaper, fresher, more consistent. And because he controlled the slaughter, he could standardize the cuts, creating a product that looked the same whether you bought it in Boston or Baltimore. This standardization would prove to be just as revolutionary as the refrigeration itself. For the first time, beef became a branded, consistent commodity rather than a variable local product. But Swift needed more than a few test runs on friendly routes. He needed to ship at scale. He needed access to the main lines that connected Chicago to the eastern markets, and that meant dealing with the railroad barons, who had every reason to crush him. When Swift walked into their offices to present his revolution, he hit a wall of solid iron. The Iron Wall, the New York Central, the Pennsylvania Railroad, the Baltimore and Ohio. They were the gatekeepers of the American economy. They owned the tracks, they set the rates, and they flatly refused to haul Andrew Chase's cars. To the modern observer, this looks like bad business. Why reject a technology that makes shipping more efficient? To the railroad tycoons of 1878, the refrigerator car looked less like an innovation and more like a parasite. These companies were trapped in one of the most dangerous psychological pits in business, the sunk cost fallacy. Over the previous 2 decades, they had poured millions of dollars into the infrastructure of the livestock system. The massive stockyards in Chicago, the network of cattle cars, the watering stations dotting the routes, the feeding pens, the specialized loading facilities. If Swift's refrigerator car succeeded, that entire network would become instantly worthless. The stockyards would go silent, the cattle cars would rot on the sidings, the watering stations would dry up. The railroads were being asked to help cannibalize their own investments. But the resistance went deeper than sunk costs. It was also about control. The livestock system gave railroads tremendous power over the entire meat industry. Ranchers needed the railroads to move cattle to market. Butchers needed the railroads to bring cattle to their cities. The railroads sat in the middle, extracting profit from both sides. Swift's system threatened to eliminate that middleman power. If dressed beef could be shipped cheaply and efficiently, the entire economic structure would shift. The railroads would become mere carriers of freight instead of controllers of the meat supply. The major eastern railroads locked arms. They instituted a blockade. No refrigerator cars on the main lines. No dressed beef. The message was clear. Stick to the old way or don't ship at all. Swift was cornered. He had the perfect technology. He had the economic proof. He had everything except the one thing that mattered most: access to the tracks. This was the moment when Swift's genius extended beyond mathematics and engineering. He understood that when the front door is locked, you find a window. And if there's no window, you build a new door. He pulled out a map and looked for a line that didn't have a seat at the table of the American Railroad cartel. He found the Grand Trunk Railway. It was a Canadian line, an outsider that skirted the northern border and cut through the Ontario Peninsula before dropping back down into New England. The Grand Trunk had no massive investments in American stockyards. They had no loyalty to the Chicago cattle barons. They were hungry for freight, and they didn't care about the politics of the Pennsylvania Railroad. Swift proposed a deal. Allow him to run his refrigerator cars on their tracks, and he would give them a monopoly on the Chicago dressed beef trade. The Grand Trunk agreed, but there was a catch. Because the other railroads refused to support the technology, they wouldn't build the cars. If Swift wanted a fleet, he would have to build it himself. The Canadian Gambit. This was the moment Gustavus Swift ceased to be a butcher and became a logistics magnate. He mortgaged everything he owned, his packing houses, his inventory, his personal property. He borrowed against his own future to commission the construction of the first fleet of Chase-designed refrigerator cars. Banks looked at his proposal and saw madness. A butcher trying to build a railroad empire against the most powerful men in America, but Swift had the numbers, and the numbers were undeniable. He convinced enough investors that the potential profit justified the astronomical risk. He wasn't purchasing vehicles. He was building a private navy to fight a trade, a war. But the cars were useless without fuel, and for the Chase design, the fuel was ice. Swift couldn't rely on the railroads to provide the ice. They had made their position clear. They wanted nothing to do with his refrigerator cars. If he wanted ice stations along the route, he would have to build them himself. So, he built that network too. He constructed a massive chain of private ice stations along the Grand Trunk route. In the winter, his crews harvested thousands of tons of block ice from the frozen Great Lakes. Teams of men sawed through feet of thick ice, cutting massive blocks that weighed hundreds of pounds each. They hauled these blocks to insulated warehouses built specifically for storage, packing them in sawdust to last through the summer heat. The scale was extraordinary. A single refrigerator car required roughly 2,000 pounds of ice for a journey from Chicago to Boston. Swift's fleet would need hundreds of tons per week during peak season. The ice houses had to be positioned at precise intervals along the route, spaced so that cars could be serviced during brief stops without disrupting the train schedule. He positioned his own employees at the depots to reload the bunkers during these stops, ensuring the convection loop never broke. These weren't railroad men. They were Swift's men, loyal to his operation, trained in the specific requirements of the Chase design. He had built a parallel infrastructure, a cold chain that bypassed the entire American establishment. The investment was staggering. The risk was existential. If the system failed, if the ice melted too quickly, or the convection loop didn't work over long distances, or if the Grand Trunk route couldn't handle the volume, Swift would lose everything. His competitors would swoop in and buy his assets for pennies on the dollar. His name would become a cautionary tale about hubris and overreach. But Swift had done the math, and the math was undeniable. The first Swift train rumbled down the Grand Trunk line in 1878. Inside the cars, beef hung in perfect rows, surrounded by falling curtains of cold air. The ice bunkers, loaded at the Chicago depot, would last the entire journey to Boston. Station workers along the route stood ready to replenish the bunkers if needed, but the system was so efficient that many cars arrived with ice still intact. The tracks were clear, the bunkers were full, the blockade was broken. The question was no longer if the system would work, but how fast it would destroy the old one. At first, the railroad barons watched with smug satisfaction. They expected Swift's gamble to fail. The Canadian route was longer. The infrastructure was untested. Surely the economics wouldn't work. Surely the ice would melt. Surely something would go wrong. They were catastrophically wrong. Swift wasn't just shipping beef anymore. He was shipping a revolution. And revolutions don't grow linearly. They explode exponentially. The moment that first train delivered perfect beef to Boston at a price no local butcher could match, the clock started ticking for the old world. Swift had proven the concept. Now he just had to scale it, and scale is where efficiency becomes a massacre. The exponential massacre. At first, it was a trickle. In 1882, the first full year of operations, Swift managed to ship about 2,633 tons of dressed beef into New York City. To the railroad barons, this was a rounding error, a nuisance they could ignore. But exponential growth is a terrifying thing when you're on the wrong side of it. By 1886, just 4 years later, that number hadn't doubled or tripled. It had exploded to nearly 70,000 tons. The dam hadn't just broken. The river had changed course entirely. This ceased to be a fair fight and became an economic massacre. Swift had moved beyond selling meat. He was weaponizing efficiency. The true weapon wasn't the cold air. It was the waste the railroads had been hauling for free. The cold chain was merely the delivery system. Swift turned that 60% waste into a war chest. By slaughtering in Chicago, he could harvest it at industrial scale. The horns became buttons and combs. The hooves became glue. The fat became soap and oleomargarine. The bones became charcoal filters for sugar refining and fertilizer for farms. They even began harvesting glands for early pharmaceuticals like pepsin and insulin. Swift had effectively left the meat business to pioneer the disassembly business. He famously bragged that he used everything but the squeal. This created a terrifying economic reality for the local butcher in Boston. Swift could sell his steak in the East for less than it cost to raise the cow, because the profit wasn't in the sirloin, it was in the soap. He used the byproducts to subsidize the meat, engaging in a brutal campaign of predatory pricing. He would roll into a new town, drop the price of beef so low that local slaughterhouses bled cash trying to match him, and wait for them to go bankrupt. Once the competition was dead, prices would tick back up. It was a siege fought with accounting rather than cannons. The major competitors, men like Philip Armour and Nelson Morris, were ruthless. But they weren't stupid. They saw the math. They saw the chase cars gliding past their expensive stockyards and realized they had two choices: adopt the refrigerator car or die. The Big Four, Swift, Armour, Morris, and Hammond, stopped fighting the technology and started consolidating the industry. They built their own fleets, copied Swift's ice networks, and turned Chicago into the slaughterhouse of the world. They didn't just share the market, they effectively became the market, owning the cars, the ice, and the slaughterhouses. The railroad barons who had tried to block the refrigerator car now found themselves in a nightmare scenario. Not only had they failed to stop the technology, but they had also lost control of the freight. The Big Four owned their own cars, which meant the railroads had become mere track operators, providing infrastructure but capturing none of the value. The Pennsylvania Railroad and the New York Central, which had rejected Swift's proposal, now watched helplessly as billions of pounds of dressed beef rolled down their tracks in privately owned cars, generating profits for the meat packers, while the railroads collected only basic haulage fees. They had preserved their stockyards and cattle cars, but those assets were now slowly becoming obsolete. The very thing they had fought to protect was dying anyway, just more slowly and painfully than if they had embraced the change. This efficiency came at a cultural cost. The Romantic era of the American West, the age of the long cattle drive and the cowboy, was being strangled by the timetable. The drover who guided herds across open plains was replaced by the logistics manager who tracked rolling stock on a graph. The cattle drive didn't end because of fences. It ended because it was too slow. The trust competition is a messy, expensive business, and Gustavus Swift was a man who detested waste. By 1885, the Big Four, Swift, Armour, Morris, and Hammond, realized that fighting each other for market share was just another form of inefficiency. So, they did what industrial titans do when they want to stop bleeding money. They stopped competing and started conspiring. They met in secret to form a revenue-sharing cartel. In smoke-filled rooms, they divided up the American map like a pie. They set prices, determined quotas, and agreed on exactly how much they would pay for cattle. The free market died in a hotel room, replaced by a calculated, synchronized machine known as the Beef Trust. The refrigerator car was the key that locked this prison door. Because the Big Four owned the cars and the ice networks, they controlled the only viable method of moving perishable food across the country. This allowed them to create a vertical trap that ensnared the entire industry. They didn't just own the slaughterhouses, they owned the cattle loan companies that financed the ranchers. If you were a rancher in Wyoming, you had effectively one buyer. If you were a butcher in Philadelphia, you had one supplier. The independent middleman was extinct, crushed by the sheer weight of logistical dominance. This created a strange paradox for the American public. On one hand, the Beef Trust was a miracle. For the first time in history, a factory worker in a tenement could afford fresh meat year-round. The price of beef dropped, and quality became consistent. But this abundance was built on a foundation of economic destruction. The independent farmer saw his profits vanish as the trust dictated the price of cattle. The local butcher was reduced to a mere retailer, forced to sell Chicago beef or nothing at all. The efficiency that filled the dinner plate was emptying the pockets of the rural producer. The power of the Beef Trust eventually became too terrifying for the government to ignore. It wasn't just a monopoly on meat. It was a monopoly on the nation's calorie supply. Legal battles raged for nearly 2 decades, culminating in the Packers' Consent Decree of 1920. The Supreme Court finally forced the Big Four to divest. They had to sell their interests in the stockyards, the rail terminals, and the cold storage warehouses. The government recognized a truth that Swift had discovered 40 years earlier. The danger lay not in the cows, but in the network. By forcing the packers to separate the product from the logistics, the courts admitted that, in the modern world, control of the supply chain was a power that superseded the market itself. The trust was broken. But the blueprint they created had already become the standard for the world. The railroads had tried to crush the refrigerator car because they saw it as a threat to their livestock infrastructure. They were right. But what they failed to understand was that the real threat wasn't to their business model. It was to the entire concept of localized, decentralized food production. The human price. The human cost of this absolute efficiency reached its boiling point in 1906 with the publication of Upton Sinclair's The Jungle. Most people remember this book for the rats and spoiled meat, the gross details that led to the creation of the Food and Drug Administration. But Sinclair hadn't intended to write a book about hygiene. As a socialist, he was writing a book about labor. He wanted to show that the packing town system treated human beings exactly like it treated the hogs. as raw material to be used up and discarded. The disassembly line speed that Swift had perfected meant that men worked at a frantic, dangerous pace, slipping on bloody floors and losing fingers to the relentless rhythm of the conveyor. Sinclair famously lamented that he aimed at the public's heart and by accident hit it in the stomach. The public demanded clean meat, but they largely ignored the broken men who processed it. The refrigerator car had made meat cheap and abundant. It had democratized protein in a way that would have been unimaginable a generation earlier. But that democratization came with hidden costs. The cowboy became a wage laborer. The independent rancher became a contract supplier. The local butcher became a retail outlet. And the packing house worker became a cog in a machine that valued speed over safety. This was the dark side of the efficiency revolution. The same system that conquered distance and decay also conquered the human element, reducing it to another input to be optimized. The railroads had feared the refrigerator car would destroy their investments. They were right, but they never imagined it would also destroy an entire way of life. The pre-industrial food system, for all its inefficiencies and limitations, had been local, personal, and human-scaled. The refrigerator car replaced it with something vast, impersonal, and optimized for throughput. The cowboys didn't disappear because the West was settled. They disappeared because their labor couldn't compete with the cold chain. The cold chain. The system Gustavus Swift and Andrew Chase built didn't vanish when the courts broke up the trust. It solidified into the invisible operating system of the modern world. When you walk into a supermarket today, you're standing in the shadow of the 1880s. The fact that a consumer can purchase a fresh, bright red steak in the dead of winter, 2,000 miles from the nearest pasture, is a direct descendant of that convection loop. Before the ice car, fresh beef was a seasonal luxury, a treat dependent on the local slaughter schedule and the mercy of the weather. The refrigerator car destroyed that limitation. It conquered the seasonality of food, flattening the calendar just as the railroad had flattened geography. The most enduring legacy isn't the meat itself, it's the logistics. Swift demonstrated that the physical network, the chain of ice stations, the fleet of rolling stock, the distribution hubs, was infinitely more valuable than the product moving through it. This is the governing logic of the global economy today. We live in a world defined by cold chains, an unbroken, invisible link of temperature-controlled environments that allows perishable goods to move across oceans as easily as they once moved across town. The railroads tried to crush the refrigerator car. Instead, they watched it reshape everything.